Good afternoon. Welcome to Lunchalytics 44 or thereabouts. Today we're talking about machine learning and AI, and kind of in the Alberta ecosystem context. We have two fantastic speakers. We have Corey Jansen from Alta ML, and we have John Murphy from Stream Technologies, kind of the big view and then a narrow view. But before we get started on that, I need to ask, how many people are here for the first time? Do we have any first timers? Oh yeah, that's great, that's good. And how many people are here from academia? Are there any academics in the house? It's probably during exams, none of them are here. Anyone from that does machine learning and AI for a day job? Raise your hands. All right, okay, so a few. And how many of you make decisions based on the results of analysis and analytics and AI and such? Raise your hands. Okay, so a few decision makers, and the rest of you are here for the free lunch. Great, welcome. So without further ado, I'm going to hand it over to Corey Jansen, who's going to talk to us about the Alberta ecosystem.
You're going to get two things from this quick presentation. The first are some of the lessons that we've learned in terms of explaining machine learning to a business audience. Because the fact of the matter is, unless the C-suite actually gets it, you're not going to have any success with your project. Second, and related to that, is some of the opportunity that we have right here in Edmonton, which again, I think ties into it. Unless the C-suite understands the opportunity that we have here, we will not be able to create the ecosystem and take advantage of the potential we have of the great things coming out of the U of A. So, I know this is a technical audience here. Please take this in the context of, here's how we've explained this. There's not going to be a whole lot of education here because this is the basics. But I've sat through so many presentations from brilliant profs who completely lose a business audience because they get into the minutia of the difference between this neural net and the other one. The average business person does not know the difference between AI, ML, and deep learning. They hear all these terms in the media, but literally have no sense of what it all means. And so they're thinking it's just a buzzword that's going to pass if they just put their head under a rock. They don't have to worry about it. So here's how I explain it. Think of comp sci, AI, ML, and deep learning as this series of Russian nesting dolls. Whereas AI is really just replicating some or all of parts of human intelligence. It's a catch-all for everything. It includes robotics, it includes natural language processing, machine vision, it's everything. It's the catch-all. It really means nothing. Because right now, ML is where all the action is. Explain that the definition of ML is an algorithm, a piece of computer software that can adapt over time when you throw large data sets at it. Now, the cat and dog example here really works well because it's actually only been not so many years since Google was really working on. We had those breakthroughs. So you say, imagine throwing 100,000 images of cats. They're all labeled as cats versus dog. Is cat, is dog. That totally resonates. Every single time I've been able to use that analogy, we've said, okay, wait a minute. So it's not about actually programming it. It's using these large data sets. But of course, the area where all the fun is within deep learning. If you try to get into definitions like multiple layers of abstraction to build data sets with high level, you lose them. Said, what I've done is talked about neural networks. Most people heard what a neural net is, right? Like you kind of go, okay, like it's trying to replicate roughly how a human brain works. And I know technically that's not correct, but you kind of paraphrase it and you say, this is how, as we've taken from a data science perspective to try to replicate some of these ideas, but the deep just means the layers of the model, and understand that this is where all the cool stuff is happening in terms of autonomous driving, where it's going. But then when you wrap it all up, the whole Russian nesting doll example kind of falls apart because, as we all know, this is more like a big Venn diagram where you have all this overlap where deep learning is eating ML, ML is eating AI, and I mean, all the breakthroughs in NLP are happening because of deep learning. So you have this overarching where when the media uses it and it's all mixed, that's correct, kind of, but also incorrect. At least from this perspective, they can come out understanding, saying, listen, most of what we're going to talk about here is ML. Let's go for it. People don't understand the difference between traditional programming and ML. And if you know the rules, just program it, right? So if this, then that, okay, all you need to do is program it. So this mental model we've used here, you know, if you have data and the answers and you're looking for the rules, I find that it takes a while to get your head around it, but this has really resonated often in actually getting that idea across, right? And at least then you can say, listen, if you know what to do, don't use ML. Just program it. The most important thing to the C-suite is return on investment. The way you get return within machine learning is through data network effects. More data means a better algorithm, means a better product, more users, and you got that virtuous circle. Use the keyword competitive advantage. Because what this is, and the reason, and this isn't all BS, this is actually the real reason why ML is going to change so much, is because those data networks that you create can create moats around your business and competitive advantages that competitors can't replicate. Great example here is with Amazon, right? Anybody can set up a bookstore. Unless you have hundreds of millions of transactions or billions of transactions and hundreds of millions of users, you're not going to be able to build a recommender system like Jeff Bezos can. The next question that you might receive when you're trying to explain and get your project justified is, well, this is just the latest hype cycle. Why is this happening now? The answer is all about hardware. Explain that none of this is new. Very, very little of it is new. That many of it goes back decades. But back then, we didn't have the processing power. We didn't have the ability to collect at a low cost, and storage costs were too high. So I've used this chart. This is actually Moore's Law going back to 1900s. And it's super cool because Moore's Law actually held prior to Gordon Moore inventing Moore's Law. It's actually really cool if you think about that, right? But as you see this doubling, you say, this is going to continue to happen, right? And this is going to allow more and more to happen. But really, we're almost more like plumbers here than anything. We're looking out and we're gathering all these algorithms, these hundreds of different algorithms. I mean, there's dozens of kind of main categories, but we're going and we're trying to take these and apply these with data sets using hardware going forward. Okay. So that's enough about on the ML 101. Hopefully that helps giving you some tangible tips. Those have all helped me to explain it and get across. There was no talk of a recurrent neural net in there, right? There was nothing technical in, but that's really helped me get the idea across. And so hopefully there's a nugget there for yourself. You may have heard that Edmonton is world-class when it comes to AI, ML, and it's true. We're top 3 in the world academically for both AI and ML as measured by academic papers. I haven't updated this chart. I'm slow playing that a little bit because we're number 3 right now. Tsinghua University is ahead of us, right? Which shows the urgency of the situation. The reason this is relevant, though, and tying back to in terms of how we justify it within your organization, is that what's happening is we're bringing some of the best and brightest from around the world, and they're coming right here to the subarctic. They have no idea where they're going to. And I'll say from my data science team, it's under 10% is naturally born in Canada. And that is a great thing because we're bringing people from all around the world and they want to start a new life here. They want to become permanent residents and Canadians. We don't have to attract them to our city. We just need to retain them. Now the bad news. As a Canadian, I'm really proud of this chart. And I know it's tough on the screen. You know, you've got Toronto, Montreal, Vancouver. We're kicking ass when it comes to startups within this country. But Edmonton is sorely, sorely lacking. And I know my friend Bruce Alton over here is going to say, hey, that's not the updated chart. That's true. And I'll get to the end. There's more companies than that now. but we're still getting our butts kicked, right? I flip this around though. It also means there's no competition on hiring. What we need is more companies hiring, more people staying here. We're still losing masters and PhDs that are coming out of the U of A. It's improved a lot in the last couple of years, but we need to have a vibrant ecosystem where there's dozens, hundreds of companies hiring. Our fingerprints are all over the history of AI. And when I say our, I mean the U of A and Amy. Former Jonathan Schaefer, former Dean of Faculty of Science, in 1992, first man-machine computer championship in checkers. I'll come back to that, don't laugh. Okay, we've all heard about Gary Kasparov and Deep Blue, but did you realize that Murray Campbell was actually U of A alumni, was on that team at IBM? Back to Dean Schaefer. So you might laugh at, okay, checkers is solved checkers. Well, you wouldn't have done all these other things within games unless you started with the simple ones, right? Like he solved checkers back in 2007, right? This is what it's built off, right? These are the type of things that you can't replicate in just a couple years. Might have heard of Dr. Michael Bowling. Of course, you could have gone back to like 2005, 2015. They've solved like almost every type of poker. Got the cover, I think it was the Journal of Science around this year. It was heads up limit for the poker players in the crowd. But it's pretty cool stuff when you think that you've solved poker. And of course, the big one, the biggest moment in all of AI was AlphaGo defeating Lee Sedol. What a lot of people don't realize is David Silver, who was a U of A grad, was on that team, and AJ Huang, it was pictured on the left there, did his postdoc here. This is why DeepMind is in town. This puts us on the map globally. Having them here is bringing back more and more of those graduates that have been outside in the Valley or somewhere else, right? And it gives us the potential to form something, to start a real ecosystem here. But make no mistake, the reason they're here is because of the academic side. It's our job now to make sure that we create jobs and wealth from the commercial side of things. And okay, there we go. Sorry. I've put up most of the logos of companies that are actually pure play startups, right? And the research labs. So we all know about DeepMind, right? But RBC Borealis is here as well. Huawei and Mitsubishi are super secret about it, but everybody knows they're here, right? And then you've got the start of an ecosystem where there's a bunch of people hiring, right? We've hired dozens in the last while, and we're going to hire dozens as much as we can over the next couple quarters. Granify, they've been doing this for longer. Granify was the lone company here for like almost a decade, right? We have we owe them a debt of gratitude that they've had people and they've kept people here. Meadow just raised $3 million, I think. Trust Science has raised 4. Dave Damer at Testfire Labs has raised a bunch. You see Stream next. And I didn't even include the companies that have been in adjacent spaces that are moving in. Dark Horse for sure should be on here. Dark Horse does more in terms of personally, I think they're the best. They're world class for visualization. And as they move into this area as an adjacent space, I mean, you could probably have a dozen other logos on here. So there is the potential here. We can be up on that board in the same way of Toronto and Montreal. And frankly, think world class. Think, why not against Beijing, right? And London, right? Because we have the pipeline. It's just a matter of us starting companies, hiring people, taking some risk, and actually putting this to work. So with that, we've touched on a couple things. Hopefully, my nuggets in terms of that very basics on ML 101 have given you a little bit of insight in terms of what works from a business audience and how to explain some of these concepts. Again, with the goal of being able to get money spent, get projects done. There's no reason we can't do it here. We've got the start of an ecosystem, and I'll look back in 5 years at this as the starting point for Edmonton to become truly world-class when it comes to not just the academic side of AI, but also the commercialization side. Thank you very much.
Thanks, Corey. Any questions? Now's your chance. at the back.
Brock.
You let Amy out of the ecosystem.
Well, but Amy's the rock in the ecosystem, right? I mean, so that was a chart of purely the startups, right?
Yeah.
And research lab, right? Brock brings up a good point. Amy has been around since 2002, but is just new now, right? And frankly, in the past, Amy didn't have the resources to get things done. There's new management in town, there's new resources. Amy is doing a ton of amazing things and should be the first step for any company wanting to build capacity internally. I would say, I mean, Brock's right over there, just newly joined there. I'd be happy to connect with any other people within. Probably could have included a whole bunch of different areas there. I also didn't talk about the fact that B is invested with U of A or that service is put in, right? And all the other elements from the large corporates, this was purely outside coming in, right? So if you had a full complete chart, you would really have Amy at the epicenter with a bunch of these other potentials that come in. But the focus here was startups in the ecosystem as opposed to that, right? But thank you for bringing that up. And the point should be made that should be the starting point for almost every organization that wants to get involved.
And if you're interested, I'll be hanging around after.
Hi, quick comment first. Sitting in the back, I saw a ton of people with phones up taking pictures and recording, which is awesome. I want everyone to know that it's also being recorded and available on the website. So if you miss anything, check it out after. And I'm sorry, I don't really know a lot about Alberta. Can you talk a little bit about the market there?
Company is Alta ML. So we're a startup in the space. We're a developer of machine learning software, and we believe that the only way to actually create great software using ML and data is to get access to unique and proprietary data sets. And so to do so, we have to build relationships with large organizations. So we go in and help organizations figure out where there's a commercial application, and then we'll actually invest and take on technical risk and co-invest dollars in building out software that then we can take and commercialize on a global scale. We're still very small. We're only about 11 months old. We're just under 30 on the team now, but closed our seed round and hopefully we'll be double, triple the size in the next 6 to 9 months.
What industries do you see like the top 2 or 3 as in Alberta probably getting the most benefit? Because you said we got to keep the AI ML talent here where we give them problems to solve. So what industries are kind of the top ones?
Great question. And I don't think there's going to be any consumer packaged goods companies in ML created here because there's no data. You can't get access to data sets. Our business plan is around financial services, oil and gas, and health. And we also think transportation, logistics, and smart cities infrastructure are also 2 big areas. So when you look at, most people don't think about the fact that we've got ATB, Service, CWP, and AIMCO all right here in Edmonton. So that gives us amazing local access to try to get to those data sets to create problems and more importantly, the business problems to be able to actually have projects. Oil and gas is obviously massive. We got to bridge the gap between Edmonton and Calgary. We've got this competition from sports within this province that is just stupid from a business perspective. The fact is that the majority of the data sets, the majority of the capital, and the majority of the business decision makers are in Calgary. But 95% of all the data science talent is here. That creates opportunity for entrepreneurs and companies within the space. Finally, if we could ever crack the code on the privacy issues around health, we've actually got a really, really unique opportunity in this province because there's 4 million people under one healthcare system. So even though that 4 million is nothing when you compare to the data sets in China, we've got a very diverse population here that can be really unique for certain problems. In most parts of the world, you don't have as large a system. So there's a lot of people working on this and trying to create sandboxes and open up that data. And if, and it's a big if that happens, we should be an absolute world leader within ML and health.
One more question?
Thanks for your time.
All right, while John's setting up, let's do our usual. Anyone here looking for a job in the space of AI ML? It's okay, you can raise your hand. Unless your employer's here, you can just wink at me. All right. Anyone looking to hire in this space? Anyone? Okay, so there's Corey. You can come talk to him. And your name is?
Hi, I'm Natasha Rafa. I recently started at Alberta Blue Cross, and we're hiring the rest of our analytics team, which includes data scientists, business intelligence analysts, and some management positions. So
There we go.
definitely check those out.
Excellent. Anyone else hiring? All right, so that's a good start. So without further ado, I'll turn it over to John Murphy. Stream Technologies, take us away.
Thanks, Dan. So I'm John Murphy. I'm the CEO of Stream, and we're here today to talk a little bit about what we do at Stream as far as artificial intelligence goes, our machine learning, if we were paying attention, neural nets. So what we do is we do spectroscopy and artificial intelligence, and the idea is to kind of change the way that detection is done in the world. Okay, so just in case some of you weren't paying attention back in physics in high school on spectroscopy, just quickly, light bounces off everything differently, right? So this desk off of every molecule, wavelengths of light bounce off differently. And if we capture those wavelengths of light and we send them to our analytics engine, we could analyze that signal and we could tell what's in the scene, okay? So here's an example. We might take a picture of a leaf, and that image would then be sent to the analytics engine, which we have running at analytics.streamtechinc.com. It would analyze it and then maybe tell you how much nitrogen is in the leaf, for example. So we can use cameras. In some cases, we use spectrometers. So these spectrometers are they're gonna capture that same light, that spectral signal coming from whatever you touch your little probe onto, but it's not going to take a picture because you just have a probe, so you just get a signal. So here we might want to take a shot of the wheat there and then have that signal go up to the analytics engine, be analyzed, and then it would tell us how much protein is in the seeds, for example. So when you look at spectroscopy and the use of machine learning, it's pretty disruptive as far as the testing in the world goes. So right now, if you want to get things tested, whether it's your blood or it could be some soil, some dirt, some plants, whatever, in a lot of cases you send it to a wet chemistry lab, and you wait a week and it comes back and you pay your money, and that whole process sucks, and it's expensive and it's time consuming. And if you could just take a picture, that's going to change things. And that's what this starts to offer. There's other replacement, not just wet chemistry. Sometimes it's expert eyeballs. You know, if you're in the agriculture industry, agronomists will look at seeds and they'll look at plants and they'll know what's going on. We can replace that as well. Because in some cases, it's very labor intensive. Even if you could see a disease, you can't walk up and down miles of a field to have a look. So this is the kind of business problem that this kind of technology is changing. So when we looked at kind of solving these problems, I looked at kind of 5 things that we better get our act together on. And I'll break this down for you. But one is we got to work with lots of camera companies, because that's part of it. We have to have a developer kit, because how do we let people actually build algorithms? And we need an online store, because there's got to be a way to monetize this. And we need a prediction model, because most people just want to use it. And underlying this whole thing, we better have a world-class analytics engine, or we're not going to be able to play. So let me just break that down for you a little bit. So we have our analytics engine. This is, you can log in today, you can sign up for free. And over on the right, I know you can't really read it. There's things like what hardware might you use, and that's where you'd access our developer kit. So I'll just break that down a little bit more. So on the hardware side, what we wanted to do was we want to work with anyone who's got a camera. Okay, so this is multispectral cameras, this is hyperspectral cameras, but it's also RGB cameras. And then what we did is we also worked with spectrometers. So we supported we worked with any ocean optic spectrometer in the world, actually. And then we built out some prototypes for drone people, and we built some prototypes to go on airplanes. And the idea is we just need to be able to capture data, right? That's kind of the play here. And we wrote an open source API just so if you're a camera manufacturer and you want to talk to our analytics engine, then you can support our API and your camera will automatically upload the data to our analytics site and away you go. So if you can now change, just think about this, we could have cameras that could start taking pictures and doing analytics and looking for invisible things in the scene. What do you want to look for? Right? And so the way that we've done this is we knew that people around the world, what they want to do is they want to be able to create their own algorithms because it's their business and they've got their own problem, right? If you're somewhere where you're trying to look for fungus in the banana leaf, that's important to you. If nitrogen in soil is important, then you care about finding that, right? You only care about what really makes sense business-wise to you. So what we do is we let anybody take about 500 pictures of a diseased plant or a non-diseased plant. Take pictures of seeds with 10% protein, 11%, 12%. We can do regression. We can do multi-class. So then the idea is that becomes the training set. That is your training sample. It uploads to the analytics engine, and you as a developer then have to just push that train button right there, the one that looks like a train, and the analytics, the neural nets will take that data and it will automatically run it all through, and in about 3 hours, it'll build a model, or what I call an algorithm. And it's an algorithm, I call it an app, because some folks are more comfortable with that. But it's a model, right? And then we'll build a report for you too. So we'll tell you how well the model runs. And we do that in about 3 hours, which is kind of cool because, a spectroscopist at the university doing a model like this using chemometrics, that's going to take about 8 months for one. But now people could just snap a picture and push the button. But if they snap a picture and push a button, how do they get it out to the rest of the world? How do they get their apps distributed? So we built an app store. So there's kind of like apps for your phone, but these are algorithm apps, right? So now you can put your app in the app store and anybody in the world can just log in and license it. And if you're the one that pushed the train button, then we'd like to cut you in on worldwide revenue and we'll give you a royalty on that. So we want to encourage everybody that's got access to any samples to be able to build an algorithm and make money. So here's one that we put some soil into. This box here is not a camera, obviously, but it is a spectrometer. So, whoops, we put that together and ran some stuff with General Mills. Now, this only used 250 samples, and I just wanted to kind of point that out. We asked people to take 500, 1,000 pictures. 2,000 is even better, right? But one of the things that we're fairly good at is building these models with low data sets. So underlying this whole model, this platform, right, is an analytics engine. So what we do is we've got a bunch of neural nets, and I just want to kind of point out, typically when you look at imaging and you look at the analytics that's happening with images today, folks are using TensorFlow and they're using spatial data, right? So they're using shape, size, texture to be able to do the analytics. And we specialize in spectral data, how the light is bouncing off. So just as an example, if you used spatial analytics like TensorFlow today, it might look at these two people, the guy standing at the bus stop and the poster here, as humans, because it's just looking at facial recognition. But if you added the spectral element to it, now I can tell you that one of those is skin and one is paper. So if you had an autonomous vehicle that was driving down the road and it had to run over one of these, if it had that information as to skin and paper, in addition to face recognition, then it would probably, run over the bus stop. We'd hope. So one of the things that Stream specializes in is the combination of spatial analytics and spectral together. Because what you'll find is if you just go to try to do spectral analytics with the tool set in TensorFlow and stuff, you're left a little light. So we've done some work over the last couple of years, and we've talked to Amy in the past, and we've been able to kind of come out with a very unique way to be able to combine these two, spatial and spectral, for a more accurate play. And at the end of the day, that's what this is about, is how accurate are your predictions? So I just popped this slide up to say that part of when we started and still what we had to do was we had to actually work with some of the early adopters, and they were folks that actually wanted to build out custom hardware. And we're not necessarily in the hardware business, but we happen to have some optical folks and engineering folks that we can help to do this. So, you know, we see things like we're working with a customer down at in the bottom there, you see a little probe. That the idea there is that goes into soil, and as fast as you would push it in, it'll read it's a spectrometer in there. So it's just gonna take the spectral information out of the dirt, and then we'll tell you how much your nutrients, your micro and macronutrients are in the soil. So this one here up above, that one, second down has got a one with a little plant. So you just kind of like take your plant leaf and put it in there. Now you just know how much, you know, whatever you'd like to know about your plant leaf. And just for fun, I'll tell you a little bit about, so then we looked at, well, how are we going to scale this around the world, right? Because that's one of the things that when we talk about being world class from Edmonton, we need to understand, we need to think globally. So we had a little chat with Canon, and they're real interested in being a supplier of hardware. And I can't say a lot more about that right now, but it's a pretty interesting discussion. Okay, so I think we already kind of talked about the business model, and then I'll just let you know that this particular one, we're working with a company, and we're a big part of this, where we have a camera that goes on an airplane, and now this camera can take images about 10 kilometers wide, multispectral, as fast as the plane can fly. The big whoop-de-doo about that for us here is that's producing, you know, 1 to 2 terabytes per flight, maybe more actually, depending on how long the flight is. But so we could be coming off of a typical day flight with 5 terabytes of data. So now we have to process that, and you know, right now we're actually trying to figure out what's the best way to do that. And who knows, maybe some of the folks around here might have some ideas of how you might actually process and analyze that kind of data with 24-hour turnaround. Anyway, that'd be fun. And I think with that, we'll take some questions. Yeah.
I'm wondering, have you been working with Alberta agriculture and forestry then?
Okay, so the question is, have we been working with Alberta agriculture and forestry? So we're doing not much, not enough. We should be, if you're from there, we should be talking. So we are doing a little bit of stuff. Alberta agriculture has got some soils in a database, actual physical dirt that we're analyzing. The forestry folks, we've talked to some of them. They actually fly the forests every 10 years and do an inventory of all the trees. It's amazing, but it's 10 years. So why couldn't you fly it multispectrally? And so, you know, we're talking about those kinds of ideas, but we don't have any active projects just yet. Any other questions? Yeah.
The price point for your services, are you finding that it will be medium and large enterprises, or are a lot of small farmers kind of getting on this? In terms of, like, I'm thinking you're analyzing the different plant health data and soil data.
Okay, so the question is about pricing. So if I can just kind of comment, when people build an algorithm, so if you build an algorithm for soil, like you mentioned there, nitrogen in soil, you actually set the price for what that app will sell for in the App Store. So you set the price. So String doesn't, because because you probably know better your industry, right? And so that might be 20 cents in prediction, or it could be 10 cents or 2 cents, whatever you set. And then that's what it is. And the way that people actually sign up is they just log into the site and they just sign up to a plan. So they get a monthly plan, and then it just kind of eats up their credits depending on how many inferences they use for how many algorithms they use. So did that answer your question? Yeah. Oh, okay.
What inspired you to build this?
So you know what inspired me is we have an awarded patent on a little cube, a little piece of glass, and it was a filter for light. And I said, hey, where can we use this? And the team said, well, we could do hyperspectral imaging. And I said, that's great. What's that? And they explained that these kinds of cameras can take pictures at multiple wavelengths. So I said, that's great. And I went around to Photonics West and I talked to the industry and I said, hey, I'll buy one of your cameras. How much? $100,000, typical. Wow. So I said, okay, maybe we could do a little bit better than that. But then I said, okay, I'll buy one of your $100,000 cameras, but what am I going to do with it? Like, what use is it? And they said, well, all you got to do is hire one of these university guys for a year and they'll build you one algorithm. So I looked at that whole situation and I said, wow, this has got to be something where we could just build an algorithm every hour. And my mother's got to be able to build it. And I said, well, how could we do that? And so we just looked around and kind of said, this is a problem. This is going to change. It's going to be big. This is very disruptive. And when we looked at artificial intelligence and kind of how much you can process, I didn't know if that was going to work. But I'll be jiggered. Like we did some testing on that, and I was just amazed at how accurate this machine learning was doing. So then it was just a matter of let's put it together and let's put a business model around it. Did I answer your question?
Yeah. Do you see it getting to the point where, like, you say we walk into an old warehouse and you have our phone, you take a picture of the ceiling and we're like, wow, this has got asbestos all up in it. Or you take a picture of all your toys that you got for Christmas and you're like, wow, there's lead paint in these or whatever.
Yeah, so you guys hear the questions, you're like, you guys, could you guys see that we could one day use our cell phones to test for lead paint and asbestos? And absolutely. So, one of the challenges with an RGB camera like we have in our cell phones is it's got 3 bands, R, G, and B, right? So what's happening is some of these cameras and some of the cell phones, they'll actually add more spectral bands. I mean, right now they're available in multispectral cameras, but that technology will come to our handheld. I mean, it's already in handheld format. So absolutely, I see that not very far away. Yeah. Yeah, question?
Who owns the intellectual property when someone trains a model and puts it in their app?
Okay, that's a good question. So who owns the intellectual property when someone builds a model? So remember that they're supplying the sample data. So they own all the sample data. And we built the model because our analytics engine just did that automatically. So if they really want the model, if they want that model, and we will make arrangements where they could actually then take that and run it with some other engine. It doesn't have to be ours. So they can have that. And they own the data. So whoever actually created it owns the data. And when we pay a royalty, that's why we pay the royalty to the folks that actually supplied that sample data. We also have, as part of our data policy, that we have the right to use that data to build better algorithms, because we'll use data from someone's corn blight algorithm to actually make the wheat algorithm better. And we'll do that behind the scenes, and we retain the right to be able to do that. Did that answer your question?
Yeah.
Okay.
Lots of questions is good.
Okay, so where are the models stored? So the algorithms and the models, they're stored right now on our site in our cloud, and we're executing against those. We also have the ability to do what we call on the edge, so that the model can be, run externally. But as far as the IP goes, we have the right to use that model, and if you want a copy of that, if you want to, you also have that as if you're the one that actually created it. Did I answer your question? Okay. Okay. I guess you got a mic. You get to go.
Yeah. Conceivably, this infrastructure you're creating could be used for more than just spectral AI problems. Like, say I have a data set and I denoted all the fraudsters and I want to throw it against your system and then resell that. Is that something you see?
Okay, so does everybody hear that question? Could we expand this platform to be able to include other stuff? Absolutely, I see that we could be able to do that. Right now, I see the next step is just other sensor data. There's just so many sensors out there, and I see that we could expand into that world. I'm not clever enough to know how we're going to expand into some of these other areas, but there's a lot of clever folks around, and I think that if we actually can get the momentum going, there'll be opportunities there to do that. Absolutely, and we've got the right attitude. Like, this is technology. If we can use this, if we can leverage it, if other people can make money on it, hey, that's what this is all about. There was a question here.
So you're providing the tools and training, so you provide kind of good documentation with it. That's what mobilized to do this. So I would really trust a lot of people to just hand over a couple of photos and then maybe think that it's
Yeah, so if you're going to actually build an algorithm, the first thing you do is you log into the site, and we're going to give you, every month you log in, you get another couple hours of free analytics every month. So you can build your own app for free. And if you need more time, just give me a call. You know what I'm saying? Like we're not trying to necessarily put up any barriers for folks to actually just go in, take a whole bunch of pictures, hit the button, and then look at the results, right? And it'll tell you, yeah, you know what? You've got 75% accuracy here, but you're looking for 95. So you're not there yet. You need more pictures. I don't know if I answered the question. Okay.
Time for one more question.
Okay.
Sort of an open-ended one. Have you any surprises come out of this as you've gone down this path, this journey? Anything that you thought, I didn't expect that, or?
So the question is, any surprises have come out of this? Because it's been a journey, right? I mean, so far we're just really getting into the commercialization part of this. Some of the surprises, it's taken longer, and I've kind of done some of this software development before in my life, so I should know better. But this stuff, it took a while to build this, longer than I'd expected. We couldn't just build the analytics side without actually building some prototypes on the hardware, because we had to understand spectral data from how photons of light work over here, all the way over here to where you can do analytics. And so that we brought all that, and our team can do the entire thing. And I didn't know that we would have to do that, but to really know what's going on at a world-class scale, we had to know this from soup to nuts. So that was a bit of an eye-opener for us as well.
All right, we'll cut it off there. Thanks so much. I'm sure John will stick around. I don't know.
Thank you.
I need to give a shout out to our sponsors, ATB Financial, gold or platinum or diamond, I'm not sure which. They've been great. Go Auto is also right up there, neck and neck. We also have Alberta Data Partnerships and Nate are also sponsors. If you'd like to sponsor, come talk to me. Even as an individual, you could have your name up on the YouTube every time we present. We are still looking for sponsors in Calgary. We'll be kicking off the Calgary program starting in the new year. So those of you who want to drive down to Calgary for Lunchalytics, free lunch, right? All right, thanks very much. We'll see you guys next month, January, to be decided what it's about. Who knows? Could be anything. Could be hockey. Who knows?